Okay, so for this next example, we have to go through and find the discontinuities, if any, for this function h of x equals absolute value of x minus 1 over x squared minus 1. And the first thing we want to do, of course, is write this thing in a factored form, because when we have it in a factored form, we know what to look for. So that's the absolute value of x minus 1 over top of x plus 1 and x minus 1. And therefore, we have two places where this function is not defined. It's simply -1 and +1. So the first thing we want to do is we want to figure out how to tackle that x minus 1, because the numerator is in absolute values and the denominator is not. So to do this, we're going to go through and use the definition of absolute value. The absolute value of a is equal to either -a if a is less than 0, or positive a if a is greater than 0. And so now we're going to let x minus 1 replace the a in this expression. So therefore, we know that the absolute value of x minus 1 is equal to the opposite of x minus 1 if x minus 1 is less than 0, or the original positive x minus 1 if x minus 1 is greater than or equal to 0, which tells us that the absolute value of x minus 1 is equal to the opposite of x minus 1, and that's going to be true if x is less than 1, or just simply x minus 1 if x is greater than or equal to 1. So we actually have a piecewise defined function here instead of an absolute value function. So let's rewrite this h of x. It's going to be a piecewise defined function now that is negative x minus 1 over x plus 1 times x minus 1 if x is less than 1, or it's x minus 1 over x plus 1 x minus 1 if x is greater than or equal to 1. So we can obviously simplify this, but before we do, we want to again take note that our function is undefined at x equals -1 and x equals +1. So we're going to need to check out what happens at those 2 points. And the first thing to do is take a look at... Okay, so now we need to find the limit at each of these points. And so let's first take a look at what happens when x is equal to +1. And before we do that, let's kind of go through and simplify this function down a little bit. So in our top piece, we can cancel out the -1, or x minus 1, I should say. So a simplified and cleaned up version of this function is h of x is equal to -1 over x plus 1, and that is if x is less than 1, or 1 over x plus 1 if our x is greater than or equal to 1. So let's first take a look at what happens when x is equal to -1. You'll notice right away that we can't find this limit by direct substitution, because -1 makes both of those pieces undefined. So this limit is not going to exist and therefore we need to look. So let's take a look at the right limit, and that right limit is going to require us to take a look at function values, which are going to be slightly to the right of -1. So let's make a quick table. We're going to have our values of x and our h of x. So let's take a look at -1.1, -1.01, and -1.001. Those function values can be obtained from a calculator or from Desmos, but you do get 10, 100, and 1,000. So it should be pretty clear that the limit as you approach -1 from the right side of this function h of x is going to be positive infinity, which again doesn't exist, but it is a direction of where we're going. So that is the limit for -1. Now let's take a look at x is equal to +1. Once again, we look at left and right limits. So if we look at the limit as x approaches 1 from the left of h of x. That means that the values are for less than 1. So that's going to be negative 1 over 1 plus 1, which is negative 1/2. Now let's take a look at the limit as x approaches 1 from the right of h of x. Those are for values that are greater than 1. And again, going back to our piecewise definition, we're going to use the second piece, so that's 1 over 1 plus 1, which is 1/2. And so once again, we see that these values do not match. They are not equal. And therefore, we have ourselves a jump discontinuity. Not sure why the pencil got thick there, but it's fine. We'll be okay. So that jump discontinuity happens at x is equal to positive 1. So both of those points are actually discontinuities. The first location, negative 1, is a vertical asymptote. And our second location, positive 1, is going to be a jump discontinuity. So let's go back and relabel the other one just because for clarity. Again, that's a vertical asymptote, and the other one's a jump. So it looks like we found and studied our discontinuities for this function. Very complicated function.